Hey folks, how you doing? Welcome to the weekly, now summertime Epiphyte live stream, where those of us who are working on this project get together and chat. If it's your first time, I'm going to go ahead and pop in the little project brochure into the comments for those of you who are tuning in from our YouTube or on LinkedIn. Oops, put it in the private chat. Um, And it being summertime, we got a couple of our key members are on vacation and one or two others running late. So, but didn't want to go too much longer without go ahead and turn it on and letting you know that we are in fact happening today. How you doing, Jay?
I'm doing pretty good. Working
Yeah.
on another project, personal, internal project. So
Yeah. No, very cool. You doing any vacations this summer or no?
I went to see my father for his 101st birthday
Oh my God!
in
Congratulations.
May.
That's great. We have that's wonderful. Yeah, my gram is about to turn 101 as well in a few weeks. So
Oh well, congratulations,
cool. Well,
hardy individuals.
yeah, yeah, well cared for as well. Well, we had a really great call last week for folks who tuned in and had a couple people that were watching the stream add some great comments. We had a new member join who I just finally noticed came in, so I sent her a message. She's in Ghana and she's a petrochemical engineer. And if you're in the audience right now and didn't see my Discord, definitely shoot us a message and let me know. Excited to get you more involved. But I thought it was a great call last week. That was great for a couple of reasons. I think is that they obviously know what they're doing. Kirsch, I'm talking about from Clarity Technologies, a direct air capture company in LA that I was lucky enough to pop into the lab for a few weeks ago. And the device that they use, while he didn't show a picture of it, is very similar in its basic shape to ours. It has a sort of bulbous chamber. It really just looks like a more sophisticated, slightly larger version. And he also pointed us in the direction of the monolithic honeycomb way of doing sorbent, and also had some suggestions around heating and sorbent replacement. So in the last week, I did some research on that, but I wanted to see quickly, Jay. I know you had to jump off early, but I kind of wanted to talk through, maybe a couple of just sort of logical progression from some of the things that he mentioned. I made a couple little images here and thought we might be
Okay.
able to chat through it. Let me just see on the Discord if anybody indicated that they are coming. Uh, oh, maybe that's why the link wasn't working. Okay, wait 1 second. Let me get Charles in here. Hang tight, folks. Some people might have gotten the wrong. Yeah, I think he was using the wrong link. Um, so we'll get Charles in from UT, which is where we're building the next system. We're going to kind of start when I get back there. I'm based in Austin. And let me just give him this real quick so I don't multitask too much. There we go. All right. 1 second, guys. Sorry. So we were really excited to have Charles and a couple other members of his team be able to tune in at this point as we're making some of these design changes. And because we want to kind of get those squared away, by the end of August, so we can go ahead and order parts. So hopefully he can join in a second. And I'll give this to him to be able to join. Okay, great. So the things I was most excited about, great. Here's Charles right here. Perfect. Hey, Charles. Sorry about the link confusion.
No, that's all right. I don't think I'm not in the Discord. I don't think so. I just
Okay. Yeah, we have a new individual link each time. Um, so what we were just talking about, Charles, you probably caught. I know you were on for the full call last week, and I think your internet was good enough to hear. That was a really illuminating one for us. That immediately trying to get down to sort of specifics. Hey, Sebastian, how are you? Oh, great, good to have you here. Hey, Sebastian, if you're interested in joining us on screen, let me know. I can shoot you over the link via LinkedIn. We had a good chat on LinkedIn. Interested to hear more about your work. So post that in the comments and I'll multitask you in here. So Charles, if the big things I think that we heard last week was that, from between my visit to Clarity Tech's lab and then what Kirsch filled in the blanks on last week, I think that we could probably, more than we thought after we ended the UPenn project, where we thought we'd probably have to make some pretty significant changes to the overall structure of the system, because Clarity Tech has almost the exact same shape and basic architecture to it. We could probably go with some of the parts with some modifications. So I wanted to talk a little bit about if we were to physically fit a monolithic honeycomb into our existing system. No problem, man. That sounds good. Yeah, Sebastian. So if we can, just kind of repurpose the parts that we already have without having to kind of wholesale come up with a new overall structure for it, that would be best. And I think what he talked about with heating was also interesting. And then I also, to the best of my limited abilities, started to look up some of the sorbents on Sigma Aldrich, like the PEI amines and stuff like that. You might even have some thoughts on that, Charles. But that we could then go ahead and proceed with just to test it out with the monolith. So, but what were your general thoughts, Charles? Your first time kind of dropping in. What were your main takeaways from what we discussed last week with Kirsch?
Yeah, I definitely think we could definitely just make basic modifications to it for at least the monolith design. I know we were saying you probably fit at least like 4 of those monoliths in the machine without making major modifications, and that would definitely be a lot more efficient.
Yeah, I was thinking 4 monoliths or 1. When I looked up, you can. This is what Kirsch told me is like those monoliths. They have them. They're ceramic monoliths. Let me go ahead and show some pictures here in case people are new here. So just to back up for a second, this is the outside of the. Let me go ahead and share here. This is the outside of the first build that we did for Epiphyte at UPenn. And a fuller picture, you can see on the left side there, that black, or right side, that black object is a fan. We turn that in and it pulls air through the other side. And so the idea is that it's going to pull it through the sorbent that we have in the middle in that square part, which you can see a little bit closer here. And then we heat that sorbent up with electro-resistive heating. So this is the way we did it previously, what we have to fix. So we've talked about it pretty extensively about why we have to fix it. The way we have it currently is that this what we call the sorbent panel slides into that square part. And in the middle of it, it has these thermocouples that you can see in the middle that heat up. And then what we did is we dumped our first sorbent on there as pellets that it was surrounding it so that it was able to heat up the sorbent. And so that was our first go at it. We very quickly learned that there's a lot of downsides to it. And we've learned specifically there's other ways to do it to solve those downsides. But one of the ways to approach that is to go with a monolith instead of just dumping all of that sorbent in there. Because one of the problems we saw with that was really pretty critical is that it basically blocks the airflow. So it makes it really, really difficult for air to actually pass through. So we wanted to say, is there a way that we could do it that was more promoted or made possible, better airflow? It was also better in terms of the overall way we heat it. But you can see on the right side there in the picture here, there's many different types of monoliths because this is a very common product. It's actually used for catalytic converters. So you can find different shapes and sizes for them that we could potentially use. And then Kirsch walked us through a process that was called, basically you're embedding sorbent into a honeycomb with a wash coating and heating process. And so it kind of embeds the sorbent into the pores. And then you can, with those little cavities there, you can go ahead and shoot air right through it, right? But that changes, obviously, not just the way that we apply the sorbent, but also the heating system. But he also gave me some really good ideas for that independently on WhatsApp. And so what I was looking at, if you look at this image here, let's assume we used a ceramic brick that was more like this, and we can find one that basically corresponds to the width that we already have. This is the thing that we just open up and we pull out our sorbent chamber. But what if we could open that up and instead just slide a monolith in that fit that, and that it was wider and bigger so that we still have a lot of surface area there, again, we might not do this. We might go with something that's more like this, like a block type of shape, similar to what he held up yesterday. The only downside of this is we're going to have to redesign the overall architecture because we can't slide a block like that. Wouldn't be able to fit. That's a solvable problem. We could put like a hinge on the back and sort of open up the front of the unit at kind of a 90-degree angle and maybe slide it in. But let's just assume for a second in principle, we're going for something more like what I just showed. And what would be interesting is if you built just a really simple set of braces on the top and the bottom that correspond to the width of the monolith, and then you can just slide a new monolith in. So that, to me, I was thinking might be a way to go. And then I'll talk to you about the heating. Again, huge proviso. I am not an engineer. I'm just sort of applying some general ideas here. And we kind of touched on this a bit last week. But I wonder, Jay and Charles, what do you think about that idea? Because, again, it allows us to kind of keep the architecture that we already have and just have a new way of doing a panel.
Chris, what is the ceramic? What's it made of?
Well, it's made of ceramic.
But I mean, do you know specifically what kind?
I'm not sure. I can find it. We could also
alumina maybe.
I was looking that up today on our, a few weeks ago, I showed that I created a little LLM, like a chat GPT, specifically where we can upload tons of different documents. You actually shared links for that. I have to get back to it. But there's a lot of different papers that are on different ways of doing it. It did mention in alumina ceramic. I'm not sure if that's what.
I mean, though, you have the specs for that product.
I'm sure we can see the spec sheet for any range of things like this that you can just order on Alibaba or online for $12 a pop, so I can see what it says in the spec sheet. But explain to me why, again,
you I guess, what does he say? He preloads the sorbent in the monolith in liquid form, lets it dry. If it's a ceramic like alumina, then heating it, we could put heaters around the sides of it, and it has good thermal conductivity. So that gives you your heating. All we just need to do is find them the right, replace that metal ceramic, sorbent holder with one with these. I think that would make a really good substitution.
And Seth just joined. Hey, Seth, how you doing?
Good. How are you?
Good. So what we're looking at here is just this idea, what it kind of really resonated with me last week. And as I thought about it this week and did a little bit of research, is like, we a few weeks ago started to think, well, maybe we wanted to do a very different overall sort of architecture for this. And then I went to LA and I saw, holy Jesus, that looks a lot like Epiphyte, what they did. And he explained why. And then it just got me back to the idea that, we've always clung to, like, let's try to use what we have, without moving on. And then after last week's discussion with Kirsch and, investigating the many, many different types of monoliths that you can get in all sorts of different sizes for cheap, could we do something where we really totally repurpose this, that we keep everything we have, we use this to our advantage, this little rectangle, and instead of the existing 80/20 sorbent panel we have, we just have some form of brace that fits on the top and the bottom of that, where you could just cozily, I don't know if that's the right word, you insert a monolith and it just sort of stands there, right? That's like extremely simple, but to me, it seems like a good idea. And I see Sebastian, who I know he knows a thing or two about this. He's an engineer working on this stuff. He said he really liked that idea in the chat. Thanks, Sebastian, for the words of encouragement. But that was kind of where we just were getting into, Seth. And I'm curious what your thoughts on that are. And Charles.
Yeah, I mean, honestly, the simplest change is to just to keep the sorbent panel and replace the 8x8 section where we have the sorbent and the netting and so forth with a small monolith. Exactly. Just replace that square. That would be the simplest thing, simplest change.
So even just looking at that, like just literally getting rid of all this hardware in there and having it be an empty frame, I guess, and then you take out the steel plate, right? Because you don't want the steel plate as a backing. You want that to be completely exposed, right? and just try to fit a monolith right into the outer frame. Yeah, that's a great idea. Let's do it.
And then it's swappable, right? Then it's easy to pull out. We have some other heating options. There's certainly the forced air that Kirsch was suggesting, but we could also heat up the frame as well.
Yeah. Well, this is what I was looking at, because Kirsch did send me a couple of other things. He was saying, and this is also, again, the beauty of, we draw heavily on off-the-shelf parts that are used in HVAC. That was the legacy of Chuck, who helped build the project in Pennsylvania, who's an HVAC engineer. Is that, there's small things, but even things you can get from HVAC that are these open electric coil heaters. And this is what Kirsch had sent me another one as well, so you could imagine something where you take a heater like that. And I went back and watched the video from last week, and you just put it there, and you have the fan goes on and it draws the cool air through, it heats it up, and then it's hot. And it's able to easily pass through. Hey, Lane.
Hi.
How are you? We were just no worries. We were just talking through some. Basically, the idea was that we've covered over the last 10 minutes is that let's use what we got, right, rather than ditching the structure. And based on what we now know about monoliths, can we come up with a monolith that'll actually fit in there? And what Seth just said is like, let's just actually gut our existing sorbent panel and take off the back steel plate in a way that we could just fit a monolith. And that might be a few monoliths that we fuse together or glue together or whatever that would fit within that square, and then place it in the chamber and insert it as we did. And then the other thing, just before he jumped on, is that Kirsch had sent me some links to different, what he thought would be potentially good ways of doing it, is if you have an open electric coil heater, abundant, they're very cheap. You can get ones from HVAC supply stores as well. We could find out which one's most appropriate. And then we would just put it in here near the inlet airflow. And then when you turn on the fan, you get cool air and it would heat it up, and it would then hot pass through the honeycomb. So that was what we said. And I don't hear anybody objecting to that. My only concern is if we did something that was big like this, it's indirect heat. I don't know. Like, is it, you're going to get a real concentration of heat air going through there, and then the rest of the monolith wouldn't be cool, which would explain an advantage of having more of a shape like this. So that's just kind of an open question that I'm not sure about, but that was where we were, Ling, before he popped on.
Okay.
So I'd like to go ahead and pass this by Kirsch one more time. And if we're good for that, just sort of add it to the list and price it out for the stuff that we order to Austin. But the other benefit it has is it makes the UPenn one more usable, that we can still, it's not as many tweaks to potentially hack that and make that work. So that was my thinking on that.
I mean, Chris, if there's a concern about how the hot air gets distributed, as it goes from the narrow to the wide, the heater can be right up against, or not right up against, but can be very close to the monolith. And maybe you put in 2, 4, however many you need to get that heat more evenly distributed, right? If they're that cheap.
Yeah, no, they're super cheap. They're like 12 bucks.
Just put multiples around the monolith around the circle close to the monolith, so not right at the entrance.
So just give it like a half an inch or something in between, so it's not directly touching it, but it's super
whatever distance we need.
Yeah.
Put something small like half an inch or an inch, and you put, instead of just having one that's about the size of the inlet tube, you have, let's say, 4 at each of the sides.
Yeah, let's do it. Again, it doesn't seem to be expensive. We just need to figure out, and again, whether they're with braces or whatever, how we affix that heater on the inside so that it doesn't make the outside of the device, scalding hot to the touch. I don't know how we solve that problem.
Well, I mean, from my experience as a homeowner, we definitely want to wrap these ducts.
Yeah. And the outside though too. Yeah, go ahead, Jay.
Yeah.
What's the dimension of the sorbent holder right now?
You remember what it is, Seth? Even roughly speaking,
It's 24 by 24.
24.
I mean, where the actual sorbent sits in the inner chamber.
It's like 8 by 8, isn't it?
I thought that was 8 by 8.
Yeah, it's 8 by 8, but like that panel is 24 by 24, and the panel is adjustable, so it's
And
not.
how
We're not
how
married
thick
to the
is it?
size.
How deep or how thick is that?
It's 1.5 inches. But like sorry, can you go back?
Which one?
Chris, can you go to the picture of the duct?
The illustration?
The photo
Let me
of
see.
the duct, the outside housing. Yeah, that one.
Here, I'll do this one here. There you go.
Yeah, so I think the thickness of the duct here is almost 3 inches.
And we'd want to do that. We don't want it to be 1.5 inches, right? And wasn't that a problem too, Ling, that Jochen was talking about? He was on vacation a little while back, that we wanted to close those holes anyway, right? There's sort of space, but there's like 1 inch basically, or 1.5 inches of extra space. Like how
we deal with that currently with the sorbent panel as is that we have the panel and then we have these spacers. They look like feet for table.
Yeah.
And they just help the sorbent panel fill the space there. I'm trying to remember the number off the top of my head without navigating away from this call, but I think total it was about 3. It was about 3 inches total. Yeah. I could be wrong. It might be 4.
Okay.
And I think we'd want that. We'd want it to be. Do you see what I'm saying? Like, we'd want to probably be able to slide something in there, and if that requires us changing the frame, or not even, I don't know, Seth, if it was like you could have a sorbent. You could have the. Let me remove that. You could have the actual monolith be a little bit thicker. Mm-hmm. You could have that be 4 inches and you could still have the frame, but it would still fit within the frame. It would just be a little bit wider out and you could just slide that guy in.
Yeah, exactly.
Yeah.
So I just looking on the website, looks like one company makes one that's like 6 by 6, and you can get it in thicknesses of between, say, 1 inch and 6 inches.
Huh.
And then you could stack them in an array, and we just need to figure out like how many we need for the amount of power this thing generates so that it's carbon neutral.
Yeah, I mean,
and that goes to how much sorbent it can, what's the how many moles of sorbent it can hold.
Yeah, I'm not gonna obsess too much about carbon neutral for the first go. That obviously is a critically important crossover that we need to make, but I'm interested in just kind of getting something that works first, and then we can optimize after. But I don't know if others are hung up on that. I feel like if we get too stuck in having it be carbon neutral or negative for the prototype, that it might close us off from pursuing the check.
Yeah, we gotta get something that works first.
Yeah.
So some, like, we definitely don't want to get something that's 24 by 24 because you can see that some of the corners there's no airflow through them, so there will be wasted space. So we probably want to go for something that's somewhere between like 10 and 16, 18 inches. I don't know if it's possible to do anything that's not a square. That may be hard logistically for the monolith, but it wouldn't be very hard to mount it if we can get something that is round, because we can just machine a stand.
They have cylindrical monoliths too. I didn't look at their sizes.
Oh,
though.
okay.
Yeah.
Yeah, that could be nice.
And then for heating, since it's ceramic and if it has good thermal conductivity, you could just wrap nichrome wire around them, just heat the whole thing instead of, instead of air, because then you'd have better coupling to the ceramic. Maybe, I don't know. There's a trade-off there.
I think Kirsch mentioned that as an option, but I thought he said that ends up not heating very evenly.
Yeah. And I think what you said, Seth, is just if we have it closer to the ceramic, it will probably be good enough for heating. But I want to make sure I understood what Ling was sort of getting at there, because with the circular part, because what I was thinking was we want to maximize the amount of monolith we can get in there, I would imagine.
Yeah. Can you pull up the picture again?
Of the monolith?
No, of the housing, from the outside.
From the outside, yeah. 1 second. Here it is.
Yeah, so you can see that in the middle, there's this rectangular rectangular prism, and in the corners, it's totally flat. Like the cones don't feed into it.
Yeah.
And so if we get a monolith that fits 24 by 24, I think the monolith will be slightly taller. We want to minimize the dimensions of the monolith, but still keep it like pretty maximal, for minimizing that way we can dip more easily or coat it more easily, maybe with less solution.
Yeah, now I get what you mean. So you mean basically this here, this whole circumference there, we would want to, because I didn't know that because I've never even laid eyes on it. You're saying that I'm here using my arrow and you guys can't see that.
Oh yeah, I can't really see, but I can imagine what you're saying. Go ahead and describe.
So basically what you're saying is those corners that jut out there in the middle, so they're not going to get any exposure in the corners because the metal is right there. And so what you're saying is, can we get as big of a circle as possible that basically fits on to the round part of the cone at its widest, at its greatest width?
Yeah, or maybe like a hexagon or octagon or something. But like maybe something like that would be easier to set up.
Well, so Ling, if one of the concerns is to make it easier to dip,
we should cut it into multiple pieces, right?
Yeah, exactly. So we could. I mean, I don't have a problem if these things are cheap. I personally don't have a problem with some of it being off in that dead space and not being used. Right, that gets us the maximum surface area. But if we want to go with a disc, we can cut that into quadrants, let's say.
Yeah.
And dip those.
Yeah, my sense is you can kind of like, I held one when I was in the office with him. You could sawzall these into whatever shape you want. So, but it would be good. Jay, I didn't know if you were looking at sites. I only brought this back up again because it does show the variety. To have ones that could, and again, we could just get a square one and just write off the things in the corner. It's easier for us to integrate into our existing, frame.
So you can cut these with a bandsaw or a sawzall?
Yeah, they have like a feel. I mean, we could my sense was you could definitely, cut it. I want to see actually it's ceramic to make sure you could do that neatly. But
ceramic typically is hard to cut. And easy to crack.
Yeah, that's right.
At least the alumina and alumina nitride spacers for heat sinks for MOSFETs are you can't cut them without special tooling.
Okay.
And even a really a couple of millimeters thick, they're difficult to cut.
All right, we'll see. One thing he does, though, when he showed us those small monoliths, is he basically just has a he's got like a little, what does it remind me of? It's like almost something that he just presses it into it. It's just a hard metal circular frame, and he just puts it in, and he turns it around and he pulls it out, almost like it's packed snow or something like that. You know what I mean? And it doesn't crack. So just looking at those two things made me think that we could probably mess around with it. But whether or not we do a square, or whether or not we find an optimal circle for it, the broader concept, I think we're all bought into here. So I'll just keep looking at what the best options are, and I'll just sort of check those with Kirsch before I put it on the list of things to order.
Can you check with him also how much sorbent gets deposited inside the monolith?
He said that last week. I listened to it again. I was surprised by how much they're able to. They said their unit, which isn't much larger than ours, they use 4 or what do they use? 10 of the bricks there. And if we had the equivalent, it'd be a different geometry. But let's say it's a third of that. Their unit was like a ton a year of storage. So I'm not sure how much sorbent is embedded in there, but it was actually more drawdown than I would have thought. But I can ask him how much.
That's good.
That wash coat really makes a difference. Really
yeah, totally. Yeah. The other thing too, I was looking at, UT is one of the largest universities in the country. And I just was looking at their departments. And Charles, I don't know if you know about like furnace availability, but they do have like a ceramics department and stuff like that. I don't know. There might be just places on campus that we could find something that needs to get to that heat.
I honestly haven't seen anything that would have to do with that. I probably could look around for it, ask around and see and get back to you on that.
Yeah.
But it will be for like a month or so.
Or even just in Austin. I mean, Austin's a big city. There's all kinds of artists, stuff like that. I also, just for fun, thinking about LCA stuff, Jay, I was like saying, could there be an ultimate direction that we go into where there's another way to achieve those high heats? And I was looking at some of these really cool devices they get really hot if you want them to, up to like 1,000 degrees, which we obviously don't want. I think he said we needed, what did he say, 250 or something like that? But they're solar thermal. They're these very cool things that they're small too. I don't know what the hell they're used for. It's for something engineering related, but down the line, if we were to think, how do we get cleaner high heat for,
heat pump maybe. I don't know if it's heat pump, because I guess, what is it? One of the car companies switched out to heat pumps, and that increased their range because they don't have to run compressor. They just move heat around instead of generating it or whatever.
Yeah.
It's a good idea.
Yeah, we'll see. But, for now, let's get one to work that, solves the problems that we had at UPenn. The other thing he said, which I was trying to kind of make sense of, and what we're talking about here, I think probably isn't optimal for this, but they don't use a vacuum because they have a low void fraction, which I guess means that most of the inside space is filled up. Did that make better sense to any of you guys in terms of how he described that? It seemed I heard a couple of of acknowledgement from David, but that seemed to be another advantage, that they managed to pull carbon down and not have to use a vacuum with it. I don't know if any of you guys remember what he said about that. It didn't make as much sense to me.
I didn't hear it, and I hadn't had a chance
to watch
the
video. My understanding is basically if you seal everything up, and then there's just not that much air in there, right? Because they've designed up this low void fraction means that it's full of stuff and there's not that much air.
Yeah.
So there's very little air they would need to pump out, right? So the volume of CO2 desorbed has nothing to do with how much air or space there is in the chamber. That's going to come out regardless. So when you have just this little bit of space for regular air and you're pulling out all this CO2, it ends up being a pretty small fraction. He said they were able to get, I think it was 80% purity that way.
Yeah. So would that be
air to be mixed in with the CO2.
Yeah. So in this kind of situation, he wasn't talking about, and you were also talking about having a heater on both sides of it to increase heat, but is it that it would just be so packed with stuff here and that the air could flow through it because of the nature of the honeycomb, that there's just not a lot of open space inside the chamber? Is that basically what he's referring to?
Yeah. So basically, if let's say, if you picture this as a cylinder, so instead of having the small diameter duct and then flaring out to the larger sorbent panel, if you imagine that everything was the same diameter,
yeah,
and you just pushed the two ends in so they're pretty close to the sorbent panel. Yeah, exactly. Now,
right.
now squish that so that there's very little space. So there's nothing in there but sorbent panel.
Yeah. Gotcha.
Then there's not a lot of room for air.
Yeah. Again, they had this, like it's shaped like this, and if it's, I guess, not a problem for them, then it probably won't be a problem for us in terms of void fraction. Although, again, their bricks are different. You know, we could do the thing too, just before we go down this road completely, like something like this that was able to actually, you know, whether it's exactly like that, but you see where I'm going with it. It's able to get closer to the end, and if you took the hardware that we have for it, the outside casing, and you had on the back of it like a hinge or something, you know what I mean? They could open up at a 90-degree angle. So you open up the front of it, you insert the sorbent blocks through the front and then close it, you know, might reduce the void fraction, but that does require more work and is a bit of a workaround. So,
I mean, I'm definitely an advocate of solving one problem at a time.
Yeah.
And, you know, so let's, if we start with the monolith, and, you know, to me, the simplest thing, especially when you talk about replicating this at different sites and, you know, different skills needed to replicate this.
Yeah.
I'm happy with the square monolith and just let those dead corners be dead.
Yeah.
But, you know, if we start with that and we don't worry about the vacuum yet, let's see what kind of purity we get before we worry about the vacuum.
Yeah. Okay. Sounds good. Hey, Charles, on the DAC team at UT, I know you guys have a range of different engineering disciplines that you guys stretch across, but what Kirsch explained last week, particularly if we get Will involved, who's a chemie, I think, did any of that sound too daunting in terms of doing the wash coating processing? And set aside whether or not we can find a furnace easily, but let's just assume we can. Everything else he explained there, does that seem to be within our set of skills that we can pull off?
Yeah, that definitely seems possible. They did a bunch of tests and they synthesized a good bit of MOF for, well, actually, what the intent was to actually put it on a monolith before the end of the year. So we could definitely do that.
Ah, that's great. How much, how big was the monolith? Was it a little tiny one he was doing just for testing, or was he making something a little bit bigger? Because I know I was looking at pricing of different types of sorbents, and MOFs are extremely expensive. Like a little bottle of it was like $800. But I don't know if we're making our own for a test. We do want to have something that people can purchase, because not everybody's going to be synthesizing MOFs when they're making an Epiphyte. But I didn't know how much he was sort of producing.
The amount that he showed us was just a small vial. I think it was just proof of concept that shows, like, it was like control test. We can definitely do more. They were just testing it a bunch of different methods to see which one yielded the most results.
Okay. All right. We'll talk to him about it.
Okay.
And that was the other question too, is like, just for this purpose of that would be amazing if we start, you know, particularly given Will's expertise and interest, if we do, you know, if he is making a MOF sorbent that we could use at the one at UT, that's fantastic. We're making a structure that's pretty open system, so we could do that and test out all kinds of sorbents using the honeycomb model. But I want to be able to buy something for the first go, and so I was looking at some of the stuff that he had recommended, like PI, amines he thought was, very, very easy to use, and it's confirmed that it works. So I was looking at some options for that. None of them are super cheap. They're around zeolite, or not zeolite cheap, but around the Luatit, like somewhere like $500-600. But I don't know how much we need to order. So I had asked him as well, but we're not going to go with the Luatit. We'll keep that at UPenn and see if it can be useful at some time later. But we'll go with something that can withstand the high heats that are required for, what is it, the calcining process? Is that what he called it? Or the heating, the high heat process to have the sorbent fully pervade the pores of the honeycomb. So I might need your help and Will's help and Kirsch's help on that, Charles, just to sort of pick a good thing from Sigma that fits the bill, and we'll add that to the bomb.
Yeah, definitely. We can probably. I'll contact him and see what his schedule is, and we can maybe get him to talk on one of these meetings.
Yeah, I'd love to. I sent him an email. I know he's probably a busy guy. If you want to reach out to him, I'd love to have him come on and as we talk about this thing, none of us chemistry people, he could talk about what's feasible and what's not, and how we would be able to do it with a lot of specifics. Do you have, Jay, in your kind of hacking experience, we can look at a range of different types of heating elements like that, but I don't know for the scale on which we're working and the heats that we need, like do you have any anything you've ever played around with that might be good to fit inside of an Epiphyte?
No, not the things I worked on were electronic heaters for electronic devices, and the stuff was built into them. So I just built the circuits to drive them.
Yeah.
And coolers, heaters that, temperature stabilize things.
Okay.
I'd have to sit down and look at what temperature we need to achieve, and over. So it would take a little bit of a trade-off study to figure that out.
Okay, I'm sure.
So if you give me the dimensions, I could give it a try.
Okay.
What the dimensions are, how much sorbent, how long that sorbent needs to be at a certain temperature. For how long.
Yeah. Okay. The other cool thing is, if we don't, just to go back to the vacuum thing, we're not using a vacuum on it. We had concerns too about the dampers, right? That the dampers weren't going to be great to be able to withstand a vacuum, where that means we could probably keep these dampers. Did we feel that the dampers shut nicely though? There was like a nice, like sort of tight close that it did really, there was no leakage there. I can't remember hearing if David thought that there was. If anybody recalls.
I don't think we really tested that.
Yeah. Okay. Cool.
I mean, any leakage there, or the gaps in the frame that are going to allow more air in, will affect our purity percentage.
Yeah.
Right. But again, I think that's a next phase problem.
Cool. Yeah, and we had just a couple other things before we pop. But one question I wanted to ask for you, Charles, is when we get back to town and then as school kind of gets going, we have a few things to figure out here, but I think we're moving in a positive direction, where I think we know the kinds of things we want to order, and we've already built one of these before, and since we're not radically changing the design, do you think what do you think a good time frame to kind of convene the team and potentially start with the building of it would be?
So generally, we start meetings around 2 weeks into the semester.
Okay.
But that's just to work with the rest of the net project, because they start their meetings, I think, the first week. So we do it like the week after.
Beginning of September.
We can get them together earlier, and we start in like August 26th or something. We can start getting some preparation started that first week, if at least I can, and Tommy as well.
Yeah, I think if we have a meeting at UT look at the facilities, talk with everybody about just a summary of the design, which now you're well acquainted with, and get everybody sort of on the page, and we can kind of plan from there. But it doesn't seem like there's probably much stopping us from making progress on this, relatively early in the semester, which is exciting. Kirsch talked about a couple other things that were really exciting. It was good to hear him say that the value of something like this, if you're building these in various different places, just to see how it performs, under different environmental conditions. So we thought that from the beginning, but to hear a real professional DAC maker, express that. See you, Jay.
I wanted to.
So go ahead.
You had talked about heating, so
yeah.
I don't know. Can you see this?
Kind of.
This is a polymer. This is a polyimide resistive heater, and these are in your car seats. When you turn your car seat on, that's what they use to heat them up.
Huh.
And so polyimide melts at around, maybe is good for like 300 degrees C or something. So if you I don't know if it's the right temperature or not, but you could see how you could put them in between sections, in between the blocks, and then this one runs on a 9 volt battery. What happened?
I wonder if this is similar to that, Jay. If you can see the picture I have there, is this just?
Oh yeah, that's a silicone pad. This is polyimide, but it's the same kind of concept. Yeah, exactly.
Yeah, so I was looking at it like this. If we had one on the bottom and on the top, so it didn't obstruct the airflow, that could be an option.
Well, you could put it on all the sides perpendicular, or parallel to the airflow, and then that way you'd have full coverage, and you might get more uniform heating.
We'll see. I mean, the only issue with I guess you could put it where it would be. I still like the idea of being able to just slide the monolith down, having to put the heating around that. And if you had the heating system that was in the core structure, that didn't move. But I can't remember what Kirsch said about that. I did share something with him, and he had some reason why he thought it might not be as good, but that might be just because they used that other process that they went with. And then the last thing I wanted to say is he, it was cool to, I was just asking him, he was mentioning some, if when we get down the road and we want to see if we can mineralize in an integrated type of way. And he mentioned a couple of, options for that, like brucite, and something as simple as sort of grounding up brucite in a solution and pumping the CO2 into that. He said that was pretty rapid. And then I also talked to my buddy, Garrett Boudinot, who's the founder of Vicarb, which is a mineralization company. And the little demo that he built that we brought to COP 28 last year in Dubai is very simple. And I've been talking to him for a while about, it's a little box, and you can hook that up and you just put a couple of ingredients in it and it mineralizes really quickly. And it has a little software component in a screen built into it that shows you the rate of mineralization that's happening. And I asked him, I was like, hey, would you want to build these at, could we maybe build, an Epiphyte at New Lab where he is in Brooklyn, where I'll see him next week. And he was like, yeah, on deck. So, that would be an interesting thing to see. There might be some solutions that we could slide in there that would allow us to, at one point look to like mineralization integration. So that was cool. So that was all I had, but I think we're kind of committing to a change in this. We obviously have to find out the particulars, but we're going to go with the existing system here. We're going to change the sorbent chamber. We're going to maximize the amount of the honeycomb that we can fit in there. Charles is not intimidated by the ability to do the wash coating process. All those parts are cheap. And we have at least some families of sorbent that we know work with this. So I think we're in a good place to, by the time I get back to Austin and Charles gets back to Austin and people are situated, to be back in a mode of planning to build. So, which makes me happy, but don't know if anybody else has any other thoughts before we sign off. All right. I don't know if Sebastian had a message there, but it looked like just a little, it's an arrow pointing up. Yeah. Or maybe that's some universal sign for yes that I don't understand. But looks like Seth answered your question. But All right, guys, cool. Well, stay cool. I hope everybody's good. Anybody have any vacations coming up that will prevent them from being here for any calls?
No,
Nope.
but I'll be in New York City next week.
No way. You want to meet up?
Oh, are you in New York City next week?
Yeah. I'm up in Albany right now, but I'll be down in the city starting Monday, and I'll be in Brooklyn for 10 days.
Okay, I'll be in Manhattan, so yeah, let's meet up.
Yeah. Oh, wow. It'll be amazing. So me and Ling have known each other for about 2.5 years, but we've never met in person. I've never met.
I'm gonna be like, I didn't expect your height or something.
I'm short. I'm only 5'8", so don't. I'll just lower your expectations in advance. So.
Oh, I'm tall for a girl, I guess.
How tall are you?
5'6".
All right. Yes, that works.
I was gonna say 5'8" is not short.
Sorry. Well, yeah. I'm not tall, but shortish. But anyway, my hair makes me more, closer to 5'10". But, anyway, awesome, Ling. I'm so happy.
Oh yeah,
to hear that.
I'm glad I mentioned.
Yeah, let's talk offline and figure out a time to. There's a couple of happy hours, like CDR happy hours, that are happening. That if you want to join those, you can meet Toby and Heather and a lot of other open air people. Matt, that will probably be there. So
yeah, can you send me some time?
Yeah, we'll totally hang. I'm excited for it.
Yeah.
All right, awesome, guys. Enjoy the rest of your week.